So Trailbits is a software security research and development firm. We admit that the technology that exists today is insufficient to keep people safe. So we try to push the boundaries on what's possible to make sure that software engineers have options for helping secure their software. In order to do that, we work with a lot of research companies. We work with DARPA and the US government to try and apply research in ways it hasn't been before. We work with technology companies to actually write software and get it in their hands in places they need it. And then we also work with anybody that builds technology to just assess the risk of what they've built and try to mitigate those risks and make the outcomes safer for when a product hits the market. So we have a lot going on under one roof, but what's really special about it is that everybody's a security engineer. So we have this massive density of security engineers that are all sitting together in one room or really one Slack channel that most other companies just can't meet. It's very rare in our field to have like 50 engineers that all have that kind of background and be able to talk to each other. Yeah, so it really pays to pay attention to all the research coming out of academia. We routinely attend academic conferences. We have a paper reading group inside the company, meets about every other week, and we do detailed reviews of other people's research. Sometimes we even invite in the authors. We'll give them, a couple $100 to say thank you, but we'll get them on a conference call with us and have them actually walk us through what they did. And what our specialty is bridging the gap between what's sometimes a theoretical piece of research and turning it into a tool that you can use. So a real core value of Trail of Bits is that we want to fill in those kinds of fundamental gaps where the world probably knows the answer, but nobody's built the code to make it happen yet. And that's why people typically approach us. Yeah, so I think a lot of the industry for software security gets a little bit of a bad rap. It's a treadmill where every year you get your yearly pen test, and people come in and they fix they find bugs in your software. They deliver you a big report that they slam down on your desk. It's 100, 200 pages long, whatever. And you go fix those bugs, or maybe you don't fix those bugs, actually more likely. And then that same firm comes back a year later and finds just another pile of bugs. So the software doesn't measurably improve its safety year over year. You're just kind of doing a process that somebody else told you to do in order to check a box instead of actually fix the software. So what we try and deliver is we try to deliver engineering improvements. We don't just tell you where the bugs are, but we try to lead you to ways that you can fix the process that made it. And sometimes that's actually development process changes or knowledge that we can share with your team, but more routinely, that's actually security tools that you can integrate into your process that provide a set of guardrails that you can't fall off. So we're really big fans of, like some people would call it DevSecOps or whatever, but continuous integration tools that provide continuous feedback to developers as they write code so that they have a helping hand. Because I can't sit next to everybody that writes code every day and watch and review every line they write. There needs to be some other kind of automated process or some other guidance that they have to make sure that the code they write is good. So we try to leave behind things like that after we're done with a given client. That's like, how does one become a security engineer? How do you develop that sense for understanding the safety of software? And that's what I think a lot of people don't. There's a really big push right now. People say there's not enough security engineers. There's just like thousands and thousands of open positions, and we need to rapidly train as many people as we can. But you can't train a security engineer. I say that you have to grow one. It's a really compositional field where you have to take knowledge of something and then combine it with security in order to be useful. So you have to learn how to be a really detail-oriented software engineer first. You have to learn distributed systems. You have to learn operating systems. You have to learn something. And then you can layer on that detailed knowledge with kind of where risks are going to pop up. And then you get to be a useful security engineer. So that kind of process can take 5, 10, 15 years to fully kind of develop. And there's ways that you can compress the time frame. You can do things like capture the flag challenges that are actually really good at teaching these things in compressed timescales. But overall, it's something that happens on the order of a decade. So that's why services from companies like mine are in a lot of demand right now. And that's why it's also rare to find people of this like density sitting together, because most companies are lucky if they can hire a single security engineer with that kind of background, no less 50. So that's how we figure it out. Yeah, so I mean, my team is a motley crew of people from lots of different backgrounds. We have people that have dropped out of high school, that have dropped out of college, that have dropped out of PhD programs. A lot of people that are just really excited about learning everything they can about software. So I think a real key thing about software security is that it's very, so I mentioned it's compositional, but it crosses kind of boundaries. You need to have low-level knowledge of how a computer works in order to be good at this field. So there's high-level knowledge, which is like, there's documentation, there's an API, you use it to do something. That's high level. Low level is you understand how that framework was made and all the different systems it interacts with in order to build whatever response it's providing to you. So that lower level knowledge and the kind of desire to understand all that is really what unifies people on the team. No matter where they came from or what specific niche within software security we work in, we always have a lower level understanding of how everything we use is built. But yeah, so we get a lot of people from the defense industry, people that are tired of working in a windowless bunker, and we move them up to New York and show them that, you know, we can be in an office with glass walls. That tends to be a good motivator. We work with a lot of people that do have academic backgrounds. They're obviously in the best position to understand research since they also came from that. We work with a lot of people that that don't have computer science backgrounds. This field isn't really well formalized. So a lot of people that work in it came to it at different stages of their life and their career. And in fact, a lot of the educational material at teaching it is not that great. So a lot of times academic credentials are a poor indicator of whether you'll be good at it. So I like to think that we have a fairly diverse crew of folks that come from all over the place, all over the world that work at Trailbits. And I'm really happy to work with each of them. So with Trailbits, we try to focus what we work on because there's only so much of this giant mess that we can really control and have an impact on. So we try to focus on the areas where we can really add value. And where we can apply the special set of skills we have to make a measurable improvement. So that means there are like larger scale trends that are happening in the security industry or happening in the technology industry, and I opt out of them because there's just little effect that I can make. But for the areas that Trailbits works on, there's a few areas that we really like to play in. So one of them is the advanced use of cryptography. A lot of people collect a lot of data, and there's a couple strategies for dealing with that. You've got, you can get rid of it, or at the end of the day, there's certain amounts of data that you have to keep. And for that data that you have to keep, in order to protect it or in order to use it effectively, a lot of people turn to different kinds of advanced cryptography. And there's a lot more options in 2019 than there really ever have been before. You can use things like zero-knowledge proofs to communicate that you have access to a certain piece of information and prove to you that I have it without actually giving you access to it. So if I was like a mortgage broker, or if you were buying a house from me and I was a mortgage broker, you wouldn't have to send me your banking details in order to prove to me that you made a certain amount of income or that you had a certain amount of cash in the bank. And that's safety all around, because then there's just less private information being sent back and forth. And that kind of capability didn't exist about 5 years ago. So we're seeing a lot of interest in using these kinds of modern technologies in ways that are very novel that few teams are equipped to understand, but ours is. We also work on blockchain technology a lot. That's another field where we get to apply a lot of really advanced research in things like symbolic execution and formal verification and just deep systems expertise, and actually use tools that don't scale as well to typical software, but actually use them on every piece of software in the blockchain industry. So that's been really fun for us. And then there's also, I think, a huge rush right now of a lot of companies to take advantage of distributed computing with things like Kubernetes, which is a software system that came out of Google initially to allow people to take the full advantage of the hardware they have. So for that, the tools and process for building those systems is really immature. And exposes you to a lot of risk. You inherit a lot of risk by adopting those tools and processes right now in 2019. So people need guidance and they need assistance from teams like ours to fully understand the ramifications of going down that technology path. So I think those are a couple of the kind of neat trends that we've been seeing and participating in at Drillbits. So we tend to stick with the defense, tech, and finance industry. So defense is really the US government funding research. There aren't any other customers in the world that I can go to that are willing to throw the amount of resources that they are at projects that sometimes last 4 years long and don't turn into anything. You can't go to a bank and say, hey, I'd like to put a team of 6 people to research this problem. I don't know if there's any solutions to it, but I'll check in with you once every 3 months if I find something. It just doesn't work. So we partner with the US government really extensively to make progress on those kinds of things. In the technology industry, we deal with mostly building software. They're the people that are really, they have a detailed understanding of what security engineers can do for you. They try to insource a lot of the technology they use and build instead of buying things off the shelf. So they appreciate the skills that we have in that regard. And then we work with the finance industry. And in the finance industry, they have a detailed understanding of risk, and they also have a regulatory requirement to reduce it. So they've been good customers and sophisticated customers for a lot of things across the board, whether it's security reviews of software and tools that they depend on, or actually hiring us to build software they can deploy across their network to reduce risk. So those are the places we like to play. There's a few that are starting to come up that aren't huge for us, like the automotive and aerospace industry are also people that I think appreciate these sorts of skills and sorts of risk, but they aren't like major players in our balance sheet in 2019. Oh yeah, sorry. That's definitely like a weird hybrid of tech and finance, right? So I think we're probably one of the largest, if not the largest, blockchain security company in the world. We have a staff of about 15 security engineers that focus exclusively on that. And we've done projects on asset custody, so helping people store cryptocurrency for banks and for just random foundations and people that launch an ICO and end up having $100 million overnight. They need to make sure they don't lose that tomorrow. We do things with blockchain design. So not everybody is satisfied with just using Bitcoin or Ethereum or whatever it is. They want to build their own platform. They want to build their own consensus framework. They want to use their own set of algorithms. So for those people, we consult with them on issues across the stack. And then with smart contracts, which are kind of like the application programming language to build complex systems on top of a blockchain. And for that, that's where we get to deploy, I think, a lot of our most fun kind of tools and techniques that come from research in order to help build extremely reliable, tiny little programs that are like trustless and decentralized to let people transact in a way that's a lot less like, I don't know what you'd call it. Yeah, in a way that's a little bit more arm's length than a typical transaction. So yeah, we do a lot with blockchain. I think it's a crazy field. It's very fun for us. It's a green field for us because there is no security technology there, and there wasn't really until we showed up. So that was really fun for us. But yeah, I'm just along for the ride. Oh yeah, so the field is somewhat intolerant of failure, right? Like you get one chance to deploy your software onto the blockchain, and then it sits there and everybody has access to all of the code and they can read it and analyze it at their leisure until they find a single flaw where they can send one transaction that steals all of your money. So a lot of the nature of the blockchain is stacked in favor of an attacker. And it puts a lot of requirements on the developer side to get it right the first time. And that's why I've really enjoyed working on projects of that nature, because people appreciate your expertise and are much more willing to listen to you, including all the crazy research ideas that we have, because they understand the need to and what would happen if they don't. So yeah, there's definitely a lot of risks there. I think finally now, after a few years of effort, a lot of the basic code correctness flaws have become easier to find. Like you're not going to get what you would call an integer overflow or something of that nature in a smart contract in today. But you are going to find more complex bugs. Like the field is always kind of evolving, and we're figuring out more of the fundamental nature of like what insecurity looks like for a blockchain application. So you're looking at things like just plain abuse of incentive models that people create, or vote buying and stealing for governance models, where it's not necessarily reliant on a software correctness issue, but it's something where an unintentional side effect of code you meant to write causes you harm. So yeah, I think there's a lot of unknowns there, and might be bad to say, but I'm excited for all the new issues that we'll discover in the future. We're definitely not at the end of them. Humans are a lot better at reacting to risk than they are in terms of preempting it. So I do think, and especially like a lot of the technology development in this field, it's challenging. Trying to be politically correct. Even though this is such a new field, there were a lot of mistakes made early on that are now difficult to move away from. So for instance, you have development languages like Solidity for Ethereum that were a good first shot at trying to make a smart contract programming language, but that should only have been a first shot. They should not be what we use forever. And now, because there's so much momentum behind programming languages like that, it's difficult to move away from to something that is clearly better. So I think that's impeding progress a little bit. And because there are so many people that want to make progress now, not a lot of people are willing to wait for what a good solution might look like, if it takes 6 months or a year or whatever to come out with. Because already, you can open up your Coinbase, your Gemini, or whatever account, and there's real money in there. So this stuff has dependencies that you can't easily migrate away from, even though it's a really immature, like rapidly evolving, brand new set of technology. So that kind of stuff gives me pause that there will be more issues in the future, and the capability to fix them is not always like as easy as it should be. We've tried to take, so like a lot of these things, I don't always want to be a solution provider. What I want to do is I actually want to provide tools that make it easy to not make mistakes. So we built a static analyzer for Solidity specifically, which is kind of half of what you get with a compiler. When you write code, the compiler will take the code and translate it to an intermediate language, and then it will review that intermediate language for like how to optimize it, how to make it fast, how to make it sometimes safe, and then it will convert it to a binary format, which is what you can actually like run. So those kind of 3 steps of the initial translation, the review of it, and then like spitting it out fully formed into something you can run. So static analyzer is the first 2. It reads the code and then it reviews the code for security issues. So we wrote a static analyzer for Solidity. It's pretty good. And we started to adapt it into a full compiler. All it's missing is the backend. So this summer we have an individual who's working on finishing that missing piece, and I hope to be able to give it to the entire rest of the community when we're done as an alternative for building software for Ethereum. And if we can do that, then the whole ecosystem will be safer, and their need to buy services from me will be lower, which also means that I need to continue to adapt to find different kinds of bugs and provide value that's a little bit more valuable, which is good. Like, it should never be a static target. I don't want to just, be a cog in a bunch of gears and just extract my rent, right? What I need to do is find ways to move the ball forward, and that's what we want to do with a lot of our internal R&D and investment in technology. How do I see? So I think in the near future, so I mentioned I think we've got really good software security tools in 2019. I don't think everybody's using them. So what I think is the short term is greater integration in the standard tools and frameworks that people have used to build these things with the security tools that are available. So whether that's static analyzers or property testers or symbolic verifiers, or formal semantics or whatever it is, there are options out there. It can be challenging for a normal developer to weigh those different options and pick a different solution path, but really they shouldn't need to. It should just come for free with the framework that you've got. And you don't need a whole bunch of choices, just use what's in front of you and you'll be okay. But right now that kind of like merging hasn't really happened. So I think that's the short term. More medium term, kind of the proliferation of formal verification tools needs to be a lot better than it is. There are some options that people have, like there's KLab, there's Manticore, there's Certora, there's a whole bunch of different formal verification tools, but they're all still too hard to use. They require people that have specialized knowledge of those low-level frameworks. So I think a lot of the development in the medium term is easier to use APIs that match normal developers' expectations for how to write, say, unit tests. And then I think longer term, we have to think less around whether the code works correctly and more about whether your intentions are expressed correctly in the code. So does this software do what I think it does? And will it behave in the way that I think it will in all these scenarios that it could? And that's more of like a modeling issue, and it's more of a design issue, and the tools and techniques and process for helping people with that, I don't think really exist yet. Right now, people have their best intentions building software, and you can make it fully correct, but then when you deploy it, it just might not work. Like it just will go sideways, and that's not a security problem right now, but I think it should be. So that's where I see, I think, it evolving. Yeah, so Trailbits has incubated a lot of technology for the 7 or 8 years that it's been around. And now we've got this massive collection of fun toys. And what I want to do is provide a way that people outside Trailbits can embed them into their own efforts and build them into products of their own. So I think we're going to have a really active licensing program where you can take some of the alien technology that like DARPA has helped us build, and you can find things to build on top of them. We've already got a couple successes in that regard. We've also tried to build our own products on top of them. For instance, right now we have our own continuous assurance system for Ethereum smart contracts. So you can have integrated with GitHub immediate security advice and guidance for every line of code that you write based on all the tools that we've developed, and you don't have to install a single thing. Sometimes we'll build it, other times I'll let other people build it, but at the end of the day, I want the software that we write to get used and to get used by a large number of people, and I'm going to do what I have to do to make that happen. Yeah. I mean, the most important thing is that people have a drive to understand the lower level details of the computers that they use. You have to know how a computer works, not how to use a computer, right? And that's always the difference in like, say, training versus education, right? You can train somebody how to use a computer. You have to educate yourself about how it works. So that requires a lot of dedication, a lot of time. It requires a lot of outside study. You can't usually go to a course and simply be taught how an operating system works. You have to go on the weekend and open up a debugger and start looking at the insides of a given piece of software. So that kind of desire to go the extra mile is absolutely what we look for when we hire people. Okay, so after a 5-year hiatus, we are now giving security trainings again. So there are a lot of people that give training in this industry, and I think a lot of it is very trendy. Like, you can go to conferences in the security industry and you can discover a new technique for breaking SCADA systems, or like whatever the hot new hacking tool is. But with Trail of Bits, we try to teach fundamental techniques. We want you to understand how to use an intermediate representation to automate your reverse engineering. So that's what we've done. We made a 1 to 5 day training that teaches you how to make the most of these brand new capabilities that are offered by modern reverse engineering tools. And the one that we've chosen to build it on top of is called Binary Ninja. So the reason is that a lot of these reverse engineering tools are very old. There's very few providers of these tools, and they haven't really been designed as much as they've evolved over time. And they've evolved to have a lot of scar tissue and a lot of legacy kind of components that don't always work the way you expect them to and are sometimes hard to change. So Binary Ninja is a from the ground up re-envisioning of how you would build a disassembler and a debugger. And they've, I think, made a really incredible tool that offers a lot more options for how to use it and how to instrument it than a lot of other alternatives. So trying to offer to people the ability to take advantage of all those new tools and all those new techniques is what we're trying to do with this course. And that exemplifies our approach in general. If you understand this, it's not, the knowledge doesn't expire. Next year, you don't have to retake a different course to keep up to date. That knowledge is always useful. It's the same way that we send our people to training. With Trail of Bits, I typically don't send people to random training courses all over the world. What I do instead is once or twice a year, I'll bring in a trainer and we'll learn something fundamental. We'll do a 5-day Rust development course. Because if you know how to write code better, that pays off over a lifetime, instead of gets you on a treadmill where you have to take another course next year. So that's what we're doing. I'm very hopeful, and I already see some success from it in the 2 days that it's been out. We've got about 5 emails or so that came in yesterday, and they keep streaming in as I rode the train into the office this morning. So I think we got a winner. So I'm just excited to do that, get back into training. So key mission for Trail of Bits is to share the knowledge that we have. And there's a lot of ways we can do that. On one hand, we can offer training courses, we can write blog posts, but sometimes you just need something bigger. So we partnered with Collide to provide a one-stop shop for everything anyone needs to know about Osquery, which is the internet's best open source endpoint agent that supports Windows, Mac, and Linux for security, performance, and reliability monitoring. Massive organizations use it in order to get a high level of detail about how their computers are currently working. Facebook built it initially. Trail of Bits was hired to add Windows support. And after that, hundreds of organizations now use it as an open source alternative to mostly expensive, closed source, and kludgy kind of endpoint technology. QueryCon is the name of the conference. Will be a place where everyone using it can come together and share how they are using it, what they've added to it, and where they expect it to go in the next few months. That'll be the 3rd week of June. Yeah, so querycon.io.